The physics project we are representing is about Hooke's law with a focus on oscillation. Hooke's law is a principle of physics that states that the force needed to extend or compress a spring by a distance is directly proportional to that distance. This would be F equals K times X, F being the force applied to the spring, K being the constant factor of the spring, and X being the change in length. The oscillation definition is the repetition of an object moving around an equilibrium position. These are the important equations involved in this project. There's the equation for the spring constant, the motion of oscillation, which comes from the experiment, and the frequency, which includes the theoretical frequency and the experimental frequency. What we did in the slide, we created a spring mass system to show oscillation. This involved looking at the spring stiffness, spring length displacement, and the mass of the hanging object. These objects included a protein bar weighing 50.2 grams, some keys weighing 90.1 grams, and the quarter-filled water bottle weighing 160.5 grams. The springs involved were a weak spring, a medium strength spring, and a strong spring. The picture on the right shows the experiment setup. This is a demonstration of our experiment. In the video, we can see as the objects are let go, oscillations are created with gravity acting on the object and the spring moving up and down. Our prediction for this is we expect that the protein bar and the strong spring would have a greater oscillation frequency, as a lighter weight on the more tense spring in a gravity-induced environment would create more oscillations per hertz, this unit being in hertz. These are the graphical representations of the data with each object and the type of spring used. This one is the weak spring. These are the medium springs. And this is the strong spring. This slide shows the constant spring calculations and the position displacements used in those calculations and the mass of the objects in kilograms. This slide shows the average spring constant for each spring after the calculations have been done. And the unit for the spring constant is newtons divided by meters. The theoretical oscillation frequency is shown here for each trial and an example of the calculations done on the left. This shows the oscillation frequency using the data from the experiment. The highlighted section focuses on emphasizing our prediction for the results. The conclusion, our prediction that the protein bar and the strong spring combination would create a greater oscillation frequency was supported, with it having an oscillation frequency of 4.49 hertz. Our theoretical showed a much higher frequency. This could have been due to the fact that we did not have multiple trials to find an average overall. Another example of Hooke's law is a toy gun consists of a spring that's attached to the back of the gun. When the trigger of the toy gun is pushed down, a bullet gets released and quickly recoils due to the spring that's attached to the base. This action is another example. Our COVID-19 disclaimer is, while executing our experiment, we ensured that we separated ourselves from other individuals and maintained proper social distancing. Other precautions such as FDA-approved face masks were also implemented in order to maintain safety within the group and from other students and professors. This concludes our presentation.